Our electricity network is undergoing its biggest expansion in nearly 50 years. Old and polluted power stations are closing, and new, cleaner energy is on the way.
National Grid has a huge job ahead of connecting up new sources of energy, renewables and other low-carbon forms. We felt that this was the time for a new approach.
We've listened to what people have said and concluded that we needed to look at trying to find an alternative design of pylon to go alongside the more traditional lattice design.
The process started with National Grid, working alongside the UK Government and the Royal Institute of British Architects to launch an international competition to find a new design. From the 6 shortlisted designs, there was one unanimous winner. Danish engineering and architect firm BYSTRUP came up with the winning design. Early on in the process, they had investigated an engineering solution that could help deliver a pylon much smaller in size than the traditional lattice tower. It was the first time that a circular monopole structure was being considered for high-voltage power lines in the UK. So over the months that followed, National Grid engineers set to work with their Danish partners to build 2 prototypes of T-pylon from what previously had just been paper designs. Could a T-pylon actually work in reality? The suspension pylon was the first prototype to be tested. It would need to be capable of carrying power lines in straight lines over great distances with enormous pressures placed on its 2 diamond earring structures. The second prototype tested is the tension T-pylon. The tension would be used when the span needs to turn corners or bend around the landscape. The central frame is the major visual difference here, needing to be capable of taking the tension from over 50 tons of wires as they try to bend the pylon to resist the turn.
National Grid was looking for a modern 21st century pylon design that would meet the aesthetic requirements, bring an innovative design concept that could be made a reality. And in the T-pylon, we think we found that.
The conventional pylon has hundreds of parts. It's basically like a large Meccano set, and it all bolts together on site. It takes quite a bit of time. The T-pylon consists of only 10 structural components plus the bolts, so it's very simple to bolt together.
From design, through testing, to reality, National Grid has now established a full family of T-pylons capable of transmitting electricity through a variety of landscapes.
For the family of pylons that we've developed, we're looking at a variety of options, different surface finishes that will best suit the environment that the T-pylons will be installed in.
BYSTRUP have gone forward with us and put this structure together. We're ecstatic, we're overjoyed.
The T-pylon gives us a fresh new option for our major transmission projects ahead. I think it will be welcomed for its design features, and happily it will also do a great job from the engineering perspectives to allow us to keep people's electricity flowing safely.
Technically, most of the development work has now been done, and it's proven that the design can work in reality. Through working with landscape architects and 3D modelling, it's now possible to provide an accurate account of how the T-pylon will fit into the UK landscape.
It's been a massive achievement to take this from concept through to something that we can actually build and use in the space of just 2 years. It's going to be really interesting to see what people think.